Good morning, respected faculties. My name is Bidulal. I am working as assistant professor in Veena Vignan Jyoti Engineering College. So my paper, I am presenting the paper third International Conference Data Science, Machine Learning, and its applications in December. So my title of the project is Multiple DC Placement in Distribution Network with the Reconfiguration Process for Active Power Loss Minimization. So in this case, the generation of power and the transmission and distribution. So among all of these cases, the distribution system will have the more losses. These losses we have to minimize by using the network reconfigurations and alignment of the network, and by applying the DZs, and we can reduce the power loss in the system. So the contents are objectives: literature survey, methodology, load flow analysis, network reconfiguration, multiple DC placement, comparison of the power losses of a 33 kV bus system, and conclusion, future scope and reference. So objective is to first to find the apply the load flow analysis. Then we have to apply we have to form the reconfiguration of network at a different algorithms, and then compare it to the 33 kV bus system, and then apply the DG system, and we can get the optimal solutions. These are the literature surveys, and these are the patents. It's a methodology to study the study of the need for network reconfigurations distribution system. Next, development of a methodological model and implementing of algorithm for network reconfiguration, and a placing of DZ, and a evaluation and comparison of the results. The objective function and the constraints are to minimize the power losses at a distribution system. We use the voltage constraint. It is a V minimum less than VI less than V maximum. The limits will be within the range, and then we have to power loss also there. So 0 less than PL, and a 0 QL less than PL. So it's a base case, power loss in base cases, and we have find the losses in the system. So I square R loss will be there. This losses we have to minimize by using the different techniques. So in this case, I am using the voltage stability index. I have to compare the receiving end voltage, sending end voltage with the impedance value and the power load power. So I am using the injected current and apparent power, and then I find the voltage stability index with the different conditions. Then I have to apply the load flow analysis for the relay distribution system by forming the branch current to bus voltage, and the bus injection to the branch current, and distribution load flow analysis. These three methods I have to use, and I have implemented the one algorithm. This is the algorithm. First we have to start the process, read the data, read the bus data and line data, form the BABC matrix, form the BCBV matrix, and find the DLF combination of BABC and BCBV. We form the DLF matrix, and first iteration is equal to 0. At first iteration it is equal to 0. So at next iteration is k is equal to k plus 1. Update the voltage values. Then we can find the previous current and present current. It greater than the tolerance values. If it is S, it goes to the iteration k plus 1. If it is no, then calculate the calculate the line flow and loss using the final bus voltage. 33 kV bus radial distribution system base configurations. So in this case we are using the slack bus or reference bus or voltage bus, and this is the thick wire shows that bus values, thin wire shows that sectionalizing switch, and a dotted line shows that tie switches. So this is the 33 kV bus system, and we have to find the voltage stability index by applying the load flow analysis. And we can find the voltage drop, which bus it has the highest voltage drop. Then we have line data for item standards. There is a number of buses, and this is the sending end voltage and the receiving end voltage, and this is the R resistance values and the reactance values. I have taken these values by simulating on the MATLAB. Then I take the bus voltage magnitude and a phase angle and a VSI before a reconfiguration network. This is the bus values, amplitude voltage, phase angle, VSI values I have taken by using the MATLAB. And I studied that. So the power loss values are base configurations are active power loss this much, and reactive power this one, and total power loss is 243.85. Before network reconfigurations, we have to apply the load flow analysis to perform the voltage stability index. at different buses. And now after reconfigurations, so the methods of regulating the structure of a feeder in the distribution system by altering the positions of a tie switches and sectionalizing switches means it's closing and opening of the switches at a, at a, at a, at one case only. The NR will look for a effective switching combination that will be improves the voltage stability index and reduce the power losses and improves the reliability. So in this case, so NR method gives a branch exchange means it's opening and closing. Next is a loop cutting means in this case when we are network will be forming, we get network will be forming, so we can get loop also. So this loop will be we have to avoid means we have to open the immediate switch. So this switch will be gives the minimum losses. So we can so minimum losses and maximum voltage boost. So in this case we have to use the four configuration. This is the first NR method 1, NR method 2, and NR method 3, and NR method 4. These all four configurations I have explained in terms in a flowchart manner. So in the first case it is a VSI is a maximum, second case VSI is a minimum, third case VSI is a maximum, and fourth case VSI is a minimum cases. So all the four cases have to apply. This is a load flow analysis. This is the algorithm. This algorithm, first we have to start the network, read the line data and bus data, and set the flag is equal to 0, and set the VSI is equal to 0, and run the distribution system and calculate the power losses and at a various conditions. Then so set the minimum VSI is equal to XX. If VSI is less than XX, then if it is case no, open the tie switches and close the sectionalizing switch. If it is S, set the VSI is equal to XX. Then find the VSI difference between the K and M, between the K and M of the tie switches, and then set the flag is equal to 0 and do the iteration and find the voltage difference between this one. If it is S, VSI K greater than VSI M. What the VSI K is the starting point of the tie switches, and VSI M is the ending of the tie switches. If it is no, then open the tie switches between the K and K minus 1, and if it is S, open the switches between the M and M minus 1. Then set the flag is equal to 1, and then if the flag is equal to 1 for all tie switches, it is if it is no, then go for the again starting onwards from load flow analysis. If it is S, we have to calculate the power losses and compare the power losses with respect to of sanity values, and if it is S, print the values and stop. If it is no, then go for the load flow analysis. So in this second method, so in second method it is the minimum VSI difference will be taken into consideration, and adjacent sectionalizing switch is to be considered, and we have to find the losses. In this case VSI K less than VSI M, and we get the minimum losses. And then next third algorithm 3, in algorithm 3 maximum VSI difference will be taken into consideration, and the minimum losses will be considered, and in this case VSI K is greater than VSI M. These conditions only changes, remaining all same procedure we have to repeat it. And in network 4, so algorithm 4 case also we are doing. So VSI K is less than VSI M. In this case the minimum VSI difference taken into consideration, and a sectionalizing switch gives the minimum losses, and then this process will be continuously we are doing, and we get the minimum power loss. So this among all the four algorithm 4 gives the better performance, and it gives. So this is the base case configurations. So now I have to observe the at bus number 22 and 12 it have the maximum voltage stability index. Then I have to close this one. Then after immediately closing the switch, it is a closure path will be forming. This closure path I have to remove by using the bus 12 and bus 11 will be open. This one is a open circuit. This is the open circuit because it is a closure path. It is not. It is a ringman system, but we are following the radial system, so we have to open this immediate switches. In first case, this is the first case, and second case I am using the 25 and 29. This is the 25 switches bus, and this 29, this is the 29 bus, and I have to close this one, and immediately I have to open this switch. immediately open the tie switches. Sorry, closing the tie switches and immediately open the sectionalizing switches. In third case, I am 33 kV bus, from 33 kV bus to 18 bus. Then I have to close this one and I have to open immediately 32 bus is open. If you not open, it is form a closed loop. That's why you have immediately adjacent bus we have to open. And we can perform the we can perform the MATLAB simulation, and we got the results. So those results are comparing now. So now this, so first case I applied at 22 and 12. So I got 156 power loss. In second case, in second tie switches 25 and 29, I got 146 kilowatt. In third case, in the third switch 18 and 33, I got 143.6. Then among all the algorithms, the algorithm 4 will be gives the best results, and the value will be 141.60 kilowatts. And this is the fourth case algorithm. This is the fourth case algorithm. This algorithm will be gives the best result compared to the all other cases. This is the network reconfiguration. After applying the four methods, this method will be gives the best results. So then after reconfigurations, I have taken this data, voltage magnitude, phase angle, and a VSI difference, and I compare the values before network reconfiguration. Then NRA1, NRA2, NRA3, and NRA4 will give the better results. Then I am applying the DC. So DC means distributed generation. There are different ways of injecting the injecting the power to the system. So this is the one of the method to reduce the power losses on the system. So in this case, we are applying the DCs like a wind data, solar data, or we can use small micro turbines, or we use reciprocating engines, or geothermal or biomass. Then we can apply at a different location. So the DC will be installed where the power loss will be more. That case, as in previous case, I have done four algorithm. In four algorithm, I have identified the some buses, the value voltage loss will be more. So that loss is that place I have to place the that area I have placed the DGs, and DG will be improves the minimizing the loss, improving the voltage profile, relieving the overload line, and improve the system stability, and improves the reliability. Then I am placing the DGs at a bus 22, and at bus 3, and at bus 19, and I got the better results. So those results are I compared in this figure. So this is the like a before network reconfigurations, and this is the after reconfiguration. NR1, NR2, NR3, NR4. So NR1 is 92, NR2 is 91 active power, NR3 106, NR4 90 point. This is the 90.39 power will be there. So this is the best way we have to reduce the power losses in the system. So then after that, I compare the results with a in bar chart. So this is the before case, and NR1, NR2, NR3, NR4, all the cases I compare the values, and I perform the graph on the MATLAB. This is the base case, and the first one is the base case, and then network reconfiguration case, and then DZ case, and then combination of DZ and network reconfiguration. I perform graph. The graph will give the better results. So conclusion is, I am applying the first load flow analysis, then I apply the network reconfiguration, and I have compared these values with the standard 33 kV bus system, and it gives a better power, better results. Means it gives the optimal here among the considerable algorithm 4 gives the optimal solution. So placement of DC is further reduce the distribution losses. So in this case, the base case will be high compared to the NR case and a DG case, and combine the NR and DG case, I got the better results and reduce the power losses in the system. So this is the future scope. This future scope will be implemented for 33 kV bus with a cut set approach of and a DG, or 69 bus with a cut set approach and a DG, and by improving the power losses and reliability. And in this case, we have to consider for the cost of the DG also into the consideration. Then these are reference, and then thank you all.